ROHM products have opened up new possibilities in the world of analog power ICs under the nano concept. Ideas that once existed as scattered points begin to converge, crystallizing in an instant and evolving into tangible technology. This is the story of engineers who relentlessly push the boundaries of a world measured in billionths, an extraordinary scale where true innovation takes shape.
Nano Pulse Technology emerged around 2015 during my time on the Advanced Power Supply Technology project. The turning point came when a customer told us ROHM's power solutions are 2 generations behind. As an engineer, the comment was a huge shock, yet that frustration became the driving force to prove otherwise. We identified 2 fundamental issues, noise and delay. But at the time, there was no clear solution. I spent months struggling to break through. One day, I brought these challenges and possibilities to Mr. Tateishi, one of the company's top engineers. We discussed various approaches, but nothing seemed concrete. Then one evening, just before heading home, a new idea came to me. By changing the way we looked at the problem, I thought this might actually work. Overjoyed, I rushed to Tateishi-san. To my surprise, he smiled and said, "I was thinking the exact same thing." It felt like an extraordinary coincidence, almost unreal. From that moment, development accelerated at lightning speed, paving the way to the widespread adoption of Nano Pulse technology. This is how it all began.
10 years have passed since its groundbreaking debut with an industry-leading 9 nanoseconds. Nano Pulse Control technology has continued to evolve, expanding its potential across a wide range of power control applications.
Development of nano energy began around the same time as Nano Pulse Control in 2015. The goal was clear: dramatically reduce power consumption in DC-DC converters. However, this challenge came with a fundamental trade-off common to all ICs. As power consumption decreases, circuit response speed, including in comparators, inevitably slows down. The key was to use 2 comparators. Conventionally, the accepted approach was to optimize a single comparator. Instead, we introduced a completely new concept, utilizing one comparator dedicated to high-speed response and another for ultra-low power. But enabling ultra-low current wasn't just about circuit design. We worked closely with the manufacturing team to develop new device structures, including specialized resistors. By overcoming these challenges one by one, we ultimately achieved a major breakthrough in reducing IC power consumption.
Innovation is not something a single superhero can accomplish alone. It begins with someone who is willing to think deeply and persistently. Around that person, you need colleagues with strong expertise and technical insight. When these people come together and engage in meaningful dialogue, a spark of inspiration suddenly can emerge, a kind of chemical reaction. I believe ROHM's analog power technologies continue to chart a distinctive, unwavering path precisely because of the synergy. Individuals who think relentlessly, others who inspire them, and an environment that allows ideas to grow and take shape.
It began with a seemingly casual suggestion from Watanabe-san, who worked on switching power supply development. Couldn't we apply switching power supply technology to LDOs as well?
This simple question sparked a new line of thinking, one that crossed departmental boundaries. Like the others, NanoCap, the 3rd nano power technology, grew through the combined insight, collaboration, and expertise of many engineers.
At the time, a global capacitor shortage drove the development of new LDO technology capable of maintaining stable operation with fewer external capacitors, laying the foundation for NanoCap. Turning this concept into a real product, however, required significant time, persistence, and collective effort.
We worked on commercialization while receiving guidance under Takobi-san, ranging from technical insights to practical implementation. The technology itself was exceptional, and I was determined to bring it to market. Yet unlocking NanoCap's full potential proved difficult, and many frustrating days followed. So I pushed hard, expressing my commitment to see this project through. Despite being in separate departments at the time, the company moved quickly, consolidating us into a single unified team. Even then, new technical hurdles kept popping up, and more people became involved along the way.
I believe that even when engineers come from different fields, they can instinctively recognize when a technology is genuinely worth pursuing. More than teamwork, I feel that one of ROHM's greatest strengths is the way technical expertise connects people's passion and commitment. And what makes me even more proud is seeing the nanotechnologies that first took root here continue to branch out, expanding into new products and applications.
When Nano Pulse technology first debuted, it was targeted at 48-volt mild hybrid automotive systems. Yet, there was a time when it seemed destined to fade away, overtaken by shifting market trends. But because its technical foundation was exceptionally strong, it survived and evolved. Today, Nano Pulse has become an indispensable core technology for switching control in 12-volt products. Just as Nano Energy and Nano Cap introduced fresh waves of innovation to the world of op-amps, I want us to continue valuing the passion that transforms unexpected ideas into real products, unchanged as we move forward.